Hello guys, welcome to my channel. Today's video is about stack. I am going to implement stack using an array. This is a Java data structure and algorithm course, and you can learn different data structures and algorithms using my videos. Stack is a linear data structure. Stack is a LIFO, last in first out, or a FILO, first in last out data structure. Operations of push and pop occur only on one end, either from the beginning of the array or the end of the array. Usage. Stack can be used in various applications. For example, Infix to Postfix conversions. Undo the mechanism to store commands or instruction. Operations are methods that I am going to implement for the array-based stack implementation. Push function, push an element at top of the stack. Pop function, pop or remove an element from the top of the stack. Peek is to look at the top element of the stack without removing it. isEmpty, check if the stack is empty. Print function to print the state of the stack. And size function to tell the number of elements within the stack. And isFull, this is array based implementation, so we need to check if the array is full or not. If it is full, we cannot push new element into the array. Stack complexity. Push function. Array based stack push function complexity is O1. This can be On in case the element is pushed at the beginning of the array, because we have to make room at the beginning of the array to push new element. Otherwise, if we push the element at the end of the array, the complexity is O1. Similarly, pop function, array based stack pop function complexity is O1. This complexity will be On. We need to shift element in case of the elements removed from the beginning of the array to fill the hole made by the pop function. That will take On time. In case removed from the end of the array, complexity will be O1. Peek function, array based peek function complexity is O1 in either case. Either we push the elements at top of the array or at the end of the array. So in this implementation, I am going to store the elements at the back of the array. So we push the elements at the end, and we pop from the end, and we peek from the end. So the complexity will be O1. That is the best performance of stack implementation. Space complexity is On because we use array. Array is a fixed data structure. Its size cannot change unless we implement a grow function to resize the array in case of it is full. So the array space requirement is On. And thank you. Let's code. Hello guys. Let's begin coding for the array stack implementation. I have created the project in NetBeans and write the tester that I will use to test the application. This is a very simple tester. Create the object of array stack, use the random number generator so that we can push the elements to the top of stack, and we loop for 5 elements, generate a random number, print the number, push it to the stack, and print the state of the stack here, peak, size, and the current stack, so that we can know each element is pushed on top of the stack. And I will use the end of stack as a pushing strategy. So we will remove and push from the end of the array. Okay, next pop. To test the pop function, we run till the stack is not empty, and we print the stack, we print the top element, then we pop the top element and print the removed top element, and then print the current stack, and it executes till the stack is empty. Okay, let's begin coding for the stack implementation. Okay, this is our stack. I wrote the skeleton code. So to save time, so maximum capacity is 100, and this is the array to store the data, and index to keep track of the current element of the stack array. So let's begin with the simple functions. Size, return, index, simple. Is full, return index is equal to 0. There is no element, is equal to capacity, max size. So when our index reaches max size, there is no more element to store. And here we return index is equal to 0. There is no element. So print function for is less than index I plus plus, and we print let's say printf percentage minus let's say 10d. This will display a fixed output of 10 characters and stack I, and that's it. Print new line so that output ends here. Okay, now over main functions. Peek is a function to check the top element at the top of the stack. So if let's say not is empty, return stack index -1. Okay, return let's say -1 to indicate an error, or we can throw new illegal argument exception, error stack is empty. You can choose whatever way you want. Let's write it here. Throws illegal argument exception. Okay, we are good to go for this function. Okay, now come here. This is our pop function. So we only pop if there is an element, means stack is not empty. If not, this dot is empty, so we pop. Okay, to pop we just reduce index minus minus. Okay, that's it. Otherwise same, array is empty. We can raise a exception. Okay, now an important thing, int element is equal to stack index -1. Okay, return the element. Now push function. Push is also a very simple function because we just push in at the end of the array if array is not full. If not is full. So what we will do, stack index plus plus is equal to value, and here we print the throw the exception, indicate stack is full, no more space. That's it. And here we allocate the memory. Allocate memory. This dot stack is equal to new int max size. Okay, this is the maximum capacity of the stack, and initialize it to index to 0. Index is equal to 0. So that's it. This is our implementation of the very simple data structure, but it is very powerful and it is used in many situations. Let's test it. something wrong. Okay, let me check what is wrong here. Okay, the error was we need to add return statement here so that the function exits instead of going to this statement. Okay, and let me add something to print. If this dot is empty, and we can print stack is empty. Okay, let's run it now. Okay, so it worked here. Okay, now we generated a number 85 on top and pushed it. Stack size is 1, stack top is 85, and current stack is 85. Okay, and we generated new number 32 and pushed it on stack. So stack size 2, top element 32. 32 is newly pushed, so first in, last out, first in, first out, first. So it becomes like this, pushed at the end of the array, and 21 pushed at the end of array, pushed at the end. And same way we pushed 5 elements at top of the stack, first, second, third, fourth, fifth. And now testing the removal. Removal will start from here. This is the last element, but it will be popped out first. 89, then we removed 1, then we removed 21, and then we removed 32, and then we removed 85, and at the end the stack is empty. This is all the implementation of the simple stack using an array. You can practice it to have a command on it. And thank you very much. Please subscribe to my channel and promote the content. See you in the next video. Next video will be a linked base stack. I'm going to implement it using linked list. Thank you guys. Have a very good day.